self-lessly family within this microphone is very sensitive.
Okay.
So,
Okay. Okay. So, hi everyone. I will be presenting about this paper, about gas and globular clusters, about the gas retention and its possible consequences. I chose this paper because last week we had a discussion in one of our classes about a common previous knowledge we knew about globular clusters, that their stars all formed at the same time and in the same generation, but it turned out that the globular clusters contain multiple distinct population of stars in our gas core, and we are trying to understand why there are different populations instead of the previous knowledge that we know. So in this paper, the main problem that they addressed is, since the globular clusters host complex stellar populations, they the observations still lack evidence for intra-cluster gas, since these chemical signatures imply early retention and reprocessing of stellar ejecta. So in this paper, they try to explain why they try to explain the accumulation, fate, and eventual removal of gas released by evolved stars in young globular clusters, and what are their implications for the production of multiple stellar populations in the globular clusters. So here in this paper, they basically use the MIST stellar evolution tracks, and this is based on the detailed stellar evolution code MESA. So MESA is usually used in stellar astrophysics simulations, and some of the results that have been I find very notable is that, let me proceed to figure 8. In this paper, they termed certain stars with masses 4.5 solar masses to 6.8 solar masses as enriching stars. So they call these range of stellar masses as enriching stars, since lower mass stars are likely to grow up to these masses. So increasing the number of stars which will produce chemically enriched stellar winds, will they try to post this as an explanation in to to explain why there are second stellar populations. So in this diagram, this basically illustrates how mass effectively flows from the most massive stars to less massive stars. So in this diagram, uh, as the mass is farther on the left, it signifies that it is much more massive. So this shows how more massive stars accrete at much higher rates than lower mass stars, and they basically evolve and re-emit the gas as stellar winds towards the lesser or least massive stars. So they also call this process stellar conveyor belt. And they have also stated in this paper, since this is part one, they will discuss more about the second population in the second paper, in paper two. But basically, in this paper, they express that one explanation why there are multiple populations in a globular cluster can be because winds from enriching stars, as mentioned earlier, could have polluted a subset of the first population to produce the second population by what we call by a mechanism called Bondi-Hoyle accretion. So they basically, in this paper, they focus on explaining some uh, some mechanisms, but they, I think, in the second paper, they will explain more about why there are multiple, like this in this graph. As you can see in the caption, if you repeat the process, like accreting like the mass being accreted to the lesser and lesser population. So as explained here, like yeah, this can be an explanation as to why there are uh, multiple generation or multiple population of stars in the globular clusters. So they express that their results basically is consistent with the recent observations of globular clusters today, which are that the globular clusters are gas poor and has multiple stellar populations. So I think that's pretty much about the paper. Yes.
Okay. Any questions? So the figure you use belong to another paper.
Yes.
Oh, it's belong to this.
Let's take it off in this game. This shows this massive this select these massive stores. It's like they it looks like a conveyor belt. Like it explains how the it's like how the mattress cycle of the globular clusters, and they try to use this as an explanation for the different stellar populations in a globular cluster.
Okay, any more questions for B? If there's no more questions, thank you very much. And let's move on to Saim Malima.
Um, Good afternoon, everyone. I'm Shamulima, and today I'll give you a brief summary on the paper of Asian Jet Evolution Simulation with Gadget for Osaka. Um, let's first start with the abstract. So, in this paper is about jet launch from the supermassive black holes, and as we know, like jets affect the galactic evolution by heating and stirring up the surrounding gas. So what the authors have done in this paper is that they have used simulation code gadget for Osaka to test how the jets evolve, and they looked at whether the growth matches with the analytic theory and also how sensitive the results are to the numerical details. And so moving on to the introduction part, like the objective of the papers are first to demonstrate how the jet's evolution can be reproduced and follows the predictable self-similar scaling laws. And second, to assess how similar the results are to the numerical factors such as viscosity, launching jets, or simulation resolution. And third, to deliver a benchmark simulation so that it can serve as a future reference model. Now, if we look at this table is actually like a menu. You can say it is like a menu for the experiments. Each row is one simulation run, and they are changing one parameter at a time. So uh, now moving on to the results for the fiducial jets. Here it's mentioned that at 20 million years, the jet reaches at a height of like 100 a kiloparsec, around 100 kiloparsec, which you can actually see on this figure, the first one, where uh, the jets have reached a height around 100 kiloparsec, and the last one where you see for a time of 100 million years, that the jets have grown to about 300 kiloparsec, which is nearly a million light years. At this point, the slope differs from the analytic self-similar profile. That means like the outer pressure is starting to push back the jet. Now, skipping all this and moving to the figure number 13. Figure 13 is actually showing the jets with different time frame, or it's showing a resolution comparison. It's showing different resolution, high and low mass resolution for different period of jets. And on the figure 14, figure 14, yeah, these plots actually shows jet length versus time, which mostly runs around 10%. And this figure shows while the theory works overall, but the details actually depends on the simulation method. And moving on to the 15 number figure, here the authors have compared two models, self-similar prediction and pressure equilibrium prediction. And if you see, which is the simulation, the blue dotted line dots, which the simulation the authors have run. Here at earlier time, the simulation actually it matches with the self-similar prediction, but as time goes on, it's moving towards the pressure equilibrium regimes, which as the outside pressure is pushing onto the jets. And it also explains why the growth stalls at later time. So these results confirm that Asian jets generally follow the analytic model, but small numerical choices like viscosity or launching method can also make a big difference. Now, to summarize the whole paper, the self-growth was predicted within 10%, and energy is conserved, but it depends on balance of kinetic and thermal setup. And also the resolution affects the fine structure, but it doesn't actually affect the overall growth. Yeah. I think that will be all.
Thank you. Any questions? So, could you remind me how they compared the simulation result in this paper to the previous theory?
Theory is actually given here. So I have the analyzing models they have used.
What is their main conclusion about this?
Main conclusion about this that they have found uh, here earlier time it's actually following the self-similar prediction which is given by the theory they have provided here, but later times as the jet grows and the outside pressure is actually pushing on the jets, it's actually the jet is getting deformed and it's breaking down.
Okay, any more questions from online people? If not, thank you very much. And let's move on to Darian.
So yeah, today I want to present about this paper. This paper is about is the interstellar object 3I/8 class alien technology. So this paper tried to discuss. So in this paper, they try to describe about the testable hypothesis. So the authors mentioned there are two theses here. The first one is the consequences. Should the hypothesis turn out to be correct, so could potentially be dire for humanity and would possibly require defensive measures to be undertaken. So, and the second one is the hypothesis is interesting exercise in its own right and it's fun to pursue. So the hypothesis here in questions is that recent interstellar visitor to our solar system, 3I Atlas, is a technological artifact and furthermore has active intelligence. If this is the case, then two possibilities follows. The first one is that its intention are entirely benign, and second, they are malign. So they this paper just tried to test what is the 3I atlas is. So if you see in the table one is the considerations that supports the hypothesis that 3I atlas is technological. So the first one is a 318 plus orbital plane is lies virtually in the ecliptic to retrograde with inclination of 175.11 degree. This P is probability of the event. And the second one is a 3I atlas is too large to be an asteroid. So actually the size is too large because typically Oumuamua asteroids is also big, right? Big asteroid, but it's large than typical. And then there is no outgassing, so it means it's no cometary activity despite expected sublimation. And then close approaches passes unusually to Venus, Mars, and Jupiter, and perihelion of geometry in October 29, 2025 occurs behind the Sun as seen from Earth. And then reverse solar orbit maneuver. So orbit maneuver is just the maneuver that takes by the spacecraft. They if the spacecraft reach the high speed point in the orbit, they burn the fuel. So they take, you know, kick, they produce more kick in that part. And then sorry. And then the directions of arrivals came from the near galactic center. It's hard to detect early. And then low delta V of for planet intercepts. The delta V is the parameters for the ship, the spacecraft, especially Mars and Jupiter, is less than 5 kilometers per second and possible have a non-gravitational accelerations. So indicate a cell-like propulsion or something. So in so that's the evidence. So I don't read the detail for this, but actually, sorry. So this is the optimal trajectory to intercept 3I Atlas with launch date of 2024 July 9, a full year earlier than the discovery. So this is the orbit's optimal trajectory. And then, so wait. So yeah, the possible strategies and motivation is probe that release with the delta V roughly 5 kilometers per second is comparable to ICBM. ICBM is intercontinental ballistic missile. So it's just to compare the scale. And 3I Atlas could release probes towards the planets. As I said, the solar orbit maneuver, they could slow into bound orbit around the sun. And the Jupiter orbit, so the planets now is the Jupiter. How about the Jupiter? Swing past Jupiter to exploit its gravity well. And in this part, non-gravitational accelerations here needed very small accelerations could explain trajectory changes. So need accelerations to reach Jupiter as this by 1.17 millimeter per second square. And such values are consistent with solar sail propulsions. I think I already, discussed about the solar sail propulsion, something like this in the previous Astroph. And a 10-kilometer radius sail of micron thickness material would match the estimated size of Atlas. And then the discussion is the sample size for saying that 3I Atlas as an alien, the sample is just small, and there are many anomalies maybe coincide. But during this period, November to December 2025, intercept prediction is testable. So they suggest that even if natural, these trajectory studies are valuable for future interstellar detections. So the conclusions of this paper, actually, they just say by far, the most likely outcome will be that 3I Atlas is completely natural interstellar object, probably a comet, and the others await the astronomical data to support this likely origin. So it's still there is a lack of data. So, but they just conclude that 3I Atlas is just like natural interstellar object is not aliens, maybe a comet. So that's paper want to say. Hmm.
Thank you. Any questions?
Oh, when? Oh, it's written in this paper. So they discovered in the 1st July 2025.
This information in the sub.
This one?
Yeah.
Yeah. So it's optimal trajectory for this, interstellar object 3I Atlas, with launch date on July 9, 2024. They, I don't know, it's like following this kind of optimal trajectory to lock in the Earth orbit, right? I think.
Yeah.
Oh no, it's yeah. Right?
Use where the try.
Hmm.
Use this like how is the resolution for it? Next.
I think it's just like a prediction, right? It's like, interpolate the data, right?
I think they have maybe pre-discovery data. Yes, so they can predict with the high eccentricity, about 6. It's hyperbolic orbit. It's not the elliptical orbit.
The address.
Yes, 3
Yes.
islands. Yeah, it's come from very far away from the solar system, and it just
Identifies the
solar system, and then but currently it's still in the solar system, but people may not be maybe cannot observe the perihelion because it's perihelion on other side sun. Yeah.
Hmm.
So they can only observe when it approaches very close to the mark. Yes.
So this time
Optically?
They can be observed at this time, or like during like you said it can be observed because on the other side.
Yes, it cannot be observed when it approaches the
Mm.
perihelion
Because it's too
because
far.
the perihelion is from other side.
So the orbit is very, huge, right? It's
Yeah.
elongated in hyperbolic. And then it's very hard if you want to observe them in the very large distances. That's why this paper said we need more, data to make sure that 3I Atlas is an alien or not. But they are just speculated that the 3I Atlas is just natural interstellar object like comets. Halley comet is also very huge object, right? It may be the same like that things.
The Halley comet is
76 years.
still elliptical orbit, right?
It's not happening. Oh, okay.
Because it go back to the solar system every
76
years.
years, yeah.
So it's not like hyperbolic.
Hmm.
Oh, what's your question?
That was my question.
So, what is the main anomaly that people consider 3I Atlas as a alien technology?
Yeah. So
Is it the non-gravitational acceleration?
based on these predictions, yes, they say that it's potentially have a non-gravitational accelerations. But the anomaly here is, I think, no, it's like that. Right? So what? So if you see this, look at the measurement of significant non-gravitational accelerations would be a huge find, right? If you can detect this, because mostly objects like asteroids have a gravitational like acceleration, like even if what's it, asteroid, but in this 3I Atlas, the signature is typically non-gravitational acceleration, but they say they lack of data, right, in here. The outers await the astronomical data to support this likely origin. So it means it's not clear yet it's non-gravitational or not. But it's possible to be non-gravitational. It's hard.
Like if it's non-gravitational, then what do you think?
So this paper suggested that if there is not gravitational, so it may be from solar propulsions. So there is a machine there, right? So if there is machine, so you can accelerate depends on your intention. So it's non-gravitational, but it's gravitational is actually attracted by nature. But I think that's the thing. But solar cell is true, and
Okay, man. What's your question?
Hi. So I just have a question. So basically, we are doomed now.
we cannot hear your voice. Wait.
Can you hear me?
Yes.
Yeah. So I just like curious. So basically, we are doomed now, right? If this is
We are.
real alien technology, then we are doomed, right? Because it can have like return in this fight, this the in the final of this year. So are we doomed?
Yeah, if it's true, right? But you know how to make it sure this is alien tech or not. Even this paper is also arguing about this in the conclusion, right? So
Yeah.
they lack of data. So I don't know how to say this is true aliens or not, but it's still speculative, right?
Oh yeah. And
Of course.
I also I know one of the professor, right, who wrote this paper, the professor from Harvard, he's have like, I mean, he was very, yeah, Abraham Loeb. He was very kind of like notorious in this kind of field because he kind, it seems like he kind of like obsessed with treating this kind of like extraterrestrial comet as a
This guy,
technology.
Avi Loeb.
Yes, I don't know. He's a
Right.
professor in Harvard.
Hmm. So he's
Yeah, he's kind of
obsessed
like
with
obsessed with treating this kind of extraterrestrial object being technological, being like, yeah, alien technology.
It's okay, but it's still speculative until now. It's hard to believe that the aliens exist actually.
Yeah, and also I just
Yeah.
have like wondering. I thought
Hmm.
the size. I mean, I thought the size of 3I Atlas is not that big, right? I think it's just hundreds of in meter, not kilometer.
Really? Hey, let me see.
I don't know. I have to search that paper again. But I thought the size of this object is not actually in
Not too big.
kilometer size.
Hmm. I don't know, but
Yeah.
I don't know, but the precise about the size of the object. But like angels ask how if they are non-gravitational asteroids, so it means they have their own machine, right?
Hmm.
But yeah, it's
Yeah.
hard to answer.
Yeah. Actually, I think this paper is very interesting.
Yeah, interesting. But or maybe you need to wait until December 2025 if we are okay.
Yeah.
So 3I Atlas is just a natural interstellar object.
Yeah. Maybe we have to
I
wait until the end of this year whether to see whether
Yeah.
we save or not.
So when our world completely destroyed and then write another paper, right?
Yeah.
But yeah, I don't know actually how to answer that question.
Yeah, this paper is actually interesting. Thank you. Thank you
Mm.
for talking about this paper.
Okay, thank you.
They don't like me.
Nesa?
NASA.
What?
I told this professor
Oh,
because they don't like
yes.
me.
Yeah. One more.
You briefly talked about solar sails. Can you remind me what
The solar sail. So
is that similar to like have you seen the movie Treasure Planet? And they have a ship with a sail.
actually,
It's powered by
and the concept is something like that. So the solar sail is like they try to catch up the solar wind. So they use a plasma to give a thrust to the machine. So last time there is a one paper analysis papers about the spacecraft that may used by the aliens, right? One of them is solar sail. So they are, describing how far they can reach the relativistic speed using this solar sail. So I think that's why this paper mentioned about the solar sail to be an indications that there is non-gravitational accelerations. Because like in relativistic regime is not gravitational, like something like in the order of G, right? It's something like that. So that's what solar sail means. Yeah, maybe we can build.
Okay, any more questions or discussion? Thank you, Darian. And I think we finished three speakers today, and let's decide who will present the paper tomorrow. I'm sorry that tomorrow I will not be here because I need to attend the EMITA training session. So please do the Astroph with Darian. Yeah. Yeah. So who want to present the paper tomorrow? No. I won't be here. Okay, Dora. Who else? Hi, Tomoki, can you present tomorrow?
Okay, I will try to do. Okay.
Okay, thank you.
This was organized the movie program for international. Was a meeting with same time as.
So how about you, Stephanie?
Yes.
Okay, so you just present the news. Yes, you don't need to go too detail with the paper. Okay, so tomorrow we have Stephanie, Dora, and Tomoki. Okay, thank you everyone for joining today, and see you tomorrow. Bye bye.
Thank you. Bye bye.
No.